Let's take a look at something called density. And we're going to define this as how much mass per volume. And you might have already heard of some things that are denser than others. That means that for the same amount of volume, some things weigh more than others. It's kind of like saying how packed in is all of the atoms in a certain type of material. Obviously, something like this is a lot less dense than something like this. This, for example, is why ice floats on water, because it's one of the few substances that in a solid state, such as this side, its molecules are not packed as closely together as they are when it's in a liquid state. Interestingly enough, ice has a density that is only 9/10 that of water. That means it's 9/10 as dense. Any substance that is less dense than another will float on that substance. A couple other examples are forthcoming, but it's why ice, when we put it in water, because it's only 9/10 as dense, only 9/10 of it are submerged. So when you see a big iceberg, what you see of that iceberg is only 1/10 of the total mass. There's a lot that you're missing. So you may have heard the story of the world's most famous shipwreck, the Titanic. When it hit that iceberg, man, there was a lot of iceberg to hit. It only saw a little bit of it. So we're going to explore how we calculate density, and it's a real simple formula. It looks like this. Calculating density is equal to the mass of the substance over the volume that it occupies. And because we're going to use a couple different units for mass, more often kilograms, less often, but only slightly less, grams, for mass, and for volume, we'll use units like the milliliter or the cubic centimeter. The unit tends to look a little strange. It's what we call a derived unit, grams per cubic centimeter or kilograms per milliliter. It's what we call a derived unit because it involves more than one. I'll show you how it works. Let's take an example here. So let's take a random block of some random material. Here's a block of aluminum. It's got a mass of 5.6 grams. Let's record that. And let's determine its volume. We'll do that by plunking it into this volume displacement basin. And we're going to measure its volume, and it comes out to a little bit more than 1 milliliter. Let's call that 1.1. I think you'll agree. And we'll calculate its density. So since we know that the formula for density is mass over volume, we have a mass of 5.6 grams with a volume of 1.1 milliliters. And I'm going to bust out my fancy calculator. We have a mass of 5.6 grams. We're going to divide that by a volume of 1.1 milliliters. And we get a density of 5.09 grams per milliliter. Call that 5.1 grams per milliliter. So if we have a block of wood that we know floats in water, or if we have a block of ice that's the same size, that also floats in water. But what would happen if we tried that with our block of aluminum? Since water has a density of roughly 1 gram per milliliter, and we just calculated the density of our aluminum is 5.1 grams per milliliter, what do we expect our aluminum is going to do? Let's find out. It sinks like a rock. So one more thing that's neat with this equation, and in fact any equation that has 3 variables in it like this, is that we can rearrange it into a mathematical device that we call the triangle of, well, I've heard a bunch of different names. We'll just call it the triangle of awesomeness. And what this does is this allows us to rearrange these 3 variables any way we want. All we have to do is look at how this triangle is set up. If we want to find density, we know it's equal to the mass over volume, and that corresponds with what we see over here. Let's say that we already know the density, and now we want to find the mass that would require a certain volume. That means we're trying to find mass. Well, that's equal to density next to volume. So that would be multiplication. Or let's say that we know the density, we know the mass, we're trying to find the volume that that particular sample would occupy. In this case, volume is going to be equal to mass over density. Let's give it a try. Let's take our aluminum block that we just calculated, and we said that for aluminum we've got a density of 5.1 grams per milliliter. And a good question that you could expect me to ask is, what volume would a 500 gram block of aluminum occupy? This is an easy one. We're trying to find volume, so we're going to use this version of our equation right here. So let's plug that in. We're trying to find what volume would a 500 gram block occupy. Volume is equal to mass over density. We know we have a mass of 500 grams. We have a density of 5.1 grams per milliliter. And what's neat about this is that the units will tell us if we've set this up correctly. In this case, grams cancels grams, leaves us with milliliters. Let me move that over a little bit. And so all we have to do is bust out our fancy schmancy calculator, and we'll say 500 grams, oops, too many zeros, divided by 5.1 grams per milliliter. We've already shown that the units are going to cancel. This particular block of aluminum would occupy a volume of 98 milliliters. And there you go. See you on the next one.